In this lesson, we are going to apply the kinematics model to solve a problem involving motion. So I'm going to use the example of a car accelerating uh, from a stop, from rest. So here's my car, and I'm going to say its initial velocity is 0 meters per second. And over here, 10 seconds later, so there's a 10-second time frame on the line here. Like that. I want to find out a couple things. However, we are given in this problem the acceleration rate of 3 meters per second squared. A couple things. You'll see a subscript 0 on the V0. That means that time equals 0. In other words, if I had a stopwatch right here, the stopwatch would be set to 0. And as time went by, then the stopwatch over here would be at, let's say, 10 seconds, like that. So the 0 just means at time equals 0, or basically at the beginning of the problem. The 3 meters per second squared, again, what does that mean? 3 meters per second squared really means 3 meters per second every second. That means I gain 3 meters per second of velocity every 1 second. And the reason why it's squared is because if you think about fractions, this is really seconds over 1. If we multiply, or excuse me, if we divide fractions, it's really 3 meters per second times, and you invert that, so it's 1 over seconds. And hence you get the 3 meters per second squared. So the second squared comes from inverting the seconds and multiplying through. At any rate, it means I gain 3 meters per second every 1 second. And what we want to find here is a couple things. A, how far do I travel? X, we call it the displacement. And what's my velocity at the end of the period here? We know I accelerate for 10 seconds, but what's my velocity? So this is a this follows a three-step process. You write the kinematic equations, which are x equals x0 plus v0t plus 1/2 a t squared. It's very common to miss that square. Make sure you write that. V is equal to v0 plus a t, and v squared is equal to v0 squared plus 2a x minus x0. So we list these equations. We list them every time so we can see what we have to work with. Different things will cancel out and so forth, which we'll see in a minute here. Then I list the variables, and I list them in these orders. Initial displacement, final displacement. Initial velocity, final velocity, my acceleration rate, and time. Be very careful and always write these in this order because it gives you a standard way to solve the problem. So this is what we do. We always put for measuring distance, imagine I put a ruler on the ground right here. If I were to put a ruler on the ground, let's say right here, I'll kind of overlay on this. It would make sense that I put the ruler, the beginning of the ruler right there, which would be 0 meters. This says, where am I at time equals 0? Well, I'm at 0 meters. That's the beginning of the motion. And 99% of the time that's going to be 0, where the motion begins. The only time it wouldn't be is if I have two things moving, like a police car chasing this car. But if I have one object, it's pretty much going to be 0 because I can place the ruler right where the motion begins. X, on the other hand, is where I'm at after this time interval, and I do not know how far that is. V0 is my initial velocity, which I'm given. It says it starts from rest, or 0 meters per second, not moving. The final velocity at the end of this period here, I do not know. We're going to actually find that. Put a box. The acceleration rate is 3 meters per second squared. And I do know that it takes 10 seconds. So this is the standard set of variables we're going to have for this type of motion. And this is really the organization here of all the information. This is the bookkeeping. This is really the physics. If you can determine what variables go here in the variables section, then step 3, solve, is just math. And it's relatively straightforward. So let's find out how far we went. X. So you look at the variables that we have here, you look at the equations, and it looks like, given what I have here, right, this is 0. Initial velocity is 0. So some of these variables drop out. So you're going to want to write these variables, these equations every time, because different things will cancel out. This is kind of your work area. So if I look here at these equations, it looks like I can use the first equation to solve for x, which is going to be x is equal to x0 plus v0t plus 1/2 at squared. As we saw a second ago, two of these already canceled out, so it simplifies it. So this is going to be 1/2 3, which is my acceleration rate, times 10 squared, and this is 100 times 300, so it's 150 meters. Units, and box your answer. So it travels 150 meters in this 10 seconds, if you accelerate 3 meters per second per second. How fast was it going at the end of this 10 seconds? Well, again, I look at the equations here, and it looks like I can use this equation right here, number 2. Looks like I could actually also use number 3 as well. So let's see here. Using the second equation, v is equal to v0 plus at. This is gone, so that's 3 times 10, or 30 meters per second. I could also use this equation. It looks like I have everything there. V squared is equal to 2a x minus x0. That's 0. This is 2 times the acceleration rate is 3 times 150, and that's v squared. So v is equal to the square root of that, 2 times 3 times 150, and if you calculate this out, it'll actually become 30 meters per second as well. You can see that this is 2 times 150 is 300, 3 times 300 is 900, and the square root of 900 is 30. So either way you do it, you get 30 meters per second. So bottom line, if the equation is here and you have the correct variables, there's no one way that it's better than the other. I could have used this to find the velocity, or I could have found this to find the velocity. So in a nutshell, when you use the kinematics model to solve problems, it's an interval. You're looking at an interval, beginning point, end point. You list the equations every single time, because you can see here this is kind of our work area. It's not just busy work. Step 2 is arguably the most important part. If you can do this part right here and get the correct variables for the beginning and end points, then step 3 is the mathematics. Looking at what equations you have, what variables you have, and then solving for the correct variables. So that's an example of a kinematics model type problem.